let's derive Kepler's third law from the Schwarzschild metric. And so we want to start with the Lagrangian, which is 1/2, right, we're GAB dxa d tau dxb d tau. So we have a minus c squared, 1 minus 2 gm over c squared r, dt d tau squared, plus 1 minus 2 gm over c squared r to the minus 1, dr d tau squared, plus r squared d theta squared, plus r squared sine squared theta d phi d tau squared. Okay, so we want, so for a equals 1, we're constructing d by d tau of the dl, the other Lagrange equations, dl by dx1 dot minus dl by dx1, and setting that equal to 0. So we're doing d by d tau of dl by dx1 is r, so it's r dot. And this is equal to d by d tau of 2 times 1 minus 2 gm over c squared r times r dot. And dl by dr is equal to, this is a little longer, right, derivative with respect to r of this. Sorry. So before it was just this term. Now we have minus 2 c squared gm over c squared r squared dt d tau squared minus 2 gm over c squared r squared, right, derivative of this term in r, times 1 minus 2 gm over c squared r to the minus 2 dr by d tau squared plus 2r d theta tau squared plus 2r sine squared theta d phi d tau squared. So let's settle into the equatorial plane. So theta equals pi over 2, and we want no radial motion. We just want phi motion. So we want r dot equals 0. We want theta dot equals 0. And so what do we get for d by d tau of dl by dr dot minus dl by dr? When we set it equal to 0, what does that look like? So let's see. So that becomes, we have the term that we derived, minus 2c squared gm over c squared r squared dt by d tau squared plus 2r d phi d tau squared, and that has to equal to 0. And so where are we? dt d tau squared is equal to r cubed over gm d phi d tau squared, and we can divide both by d phi d tau squared, and that gives us dt by d phi squared equals r cubed over gm, and therefore dt, right, dt squared is equal to r cubed over gm d phi squared, and so dt is r cubed over gm square root d phi. Let's integrate. We'll get the time, the coordinate time t for the period for going around once. We'll call it capital T, and that's equal to r cubed over gm square root times 2 pi. And that's the relationship between the period and the radial distance. All right, that's the 3/2 law for Kepler's law.